So friends, here is the next question. What are the assumptions of linear regression? Now this is a very, very basic, but it's a good question which everybody should know, right? We all know what linear regression is, but what are the assumptions behind linear regression is something which we have to understand. So overall, there are four major assumptions or main assumptions. The first is very obvious, that the linear relationship. We are assuming that x and y, my predicted variable y and my dependent and independent variable, they have a linear relationship. My x and y has a linear relationship. That's one of the central assumption. If my underlying data is not a linear relation, no matter what I do, what magic I do on linear regression, it will never be a good fit, right? So the basic assumption is that data has a linear relationship between x and y. Okay, so this particular graph which you see, this looks like, okay, this is y, this is x, and this has a sort of linear relationship. If suppose your data is represented like this, y is x, this is y, and this is x, does it look like a linear relation? It is some relation, but it's definitely not linear, right? Can we fit a best fit line over here? No, we cannot do. So if this is not the case, we should not do linear regression without transforming the data. Over here, if you see, this looks like a quadratic, right? A parabolic sort of graph. It is clearly not linear, right? The relationship between x and y is not linear, right? What should we do over here? Should we throw it away? No, linear regression can still work if we transform the data. Okay, so either we do some feature engineering task and we do a log transformation or polynomial transformations. So we create a new feature over here, which is x bar, which is x square of x, right? Then you will see, friends, that it will become a linear relation. So x bar will have a linear relation with x, where x bar is nothing but x square. Okay, so we have to do certain feature engineering, some log or polynomial transformation to make it linear. That's the first assumption, that the data is linear. Second is autocorrelation. We assume that there is no autocorrelation. What is autocorrelation? Correlation is something when it happens between two features. That is correlation. That if one feature is going up, another feature is also going up. That is correlation. What is autocorrelation? As the name suggests, it is correlation among itself. So my data in a particular feature is correlated with itself. Think about a situation where it will happen. It happens very frequently in time series data. Okay, so if the value of a column or a feature are correlated with the values of that column feature itself, it is called autocorrelation. Okay, now how do we identify? There are various ways to identify autocorrelation. I do not want to go into that detail, but there is a technique using which what you do is that you take that feature and you lag it, or you shift the numbers by one. Let's say it's a time series data, so you shift the data by 1 timestamp or 2 timestamp or 3 timestamps. Okay, and then you try to run the correlations between shifted and between original, and if you are getting a correlation between them, that means that the data is autocorrelation. So many a times in stock market prices or temperature, right, you will find the data is autocorrelated. Okay, in those cases, in stock price predictions or temperature or weather forecasting, those are the sort of time series data, right? Because my y-axis will always be the time intervals, right? And my x-axis, my another feature will be your temperature or stock prices. So we have to be careful about the autocorrelation also. The third assumption is homoscedasticity. What is homoscedasticity? Homoscedasticity says that the residual have constant variance at every level of x. Now what does it mean? Let me just zoom it. Okay, homoscedasticity says that this is my x. Okay, this line is x. Okay, my feature, x feature. Let's assume that it's one feature only. This is feature, and this is my residual plot. Residual plots means the best fit line and the delta difference between the predicted and the observed. what is predicted, what is observed. The difference between that is called residual, right? In case of linear regression, if I plot all the residuals, it should be randomly distributed across my x-axis, right? Okay, it should not have these type of shapes, either the bow shape or fan shape or funnel shape. It should not have. It should be have constant variance. That means it should be randomly distributed. It should be like this. In this situation is called homoscedasticity. If it is this, there is a pattern which is identifiable, right? Like this is a funnel shape, this is a bow shape, then this is called heteroscedasticity. Homoscedasticity is one of the key assumptions of linear regression, that the variance is randomly distributed across my x-axis. There is no pattern. Okay. Now the fourth thing is multicollinearity. This is very obvious. What is multicollinearity? Is that between my feature 1 and feature 2, there is a correlation between them, right? If there is a correlation, then my predictive power of my linear regression will go down. Okay, my coefficients which I will get will all over the place. They will not make intuitive sense also. When it will happen? If there is a very strong correlation. Let's say one feature is length of left leg and the other feature is the length of right leg. If we have two features over there, do you think the length of left leg and the length of right leg are correlated? Probably, perhaps the correlation is 1. They are perfectly positively correlated. If you have such sort of data, then your linear regression will not give you a good result. In that case, you have to drop one feature and you have to remove multicollinearity to get the better predictive power from your linear regression. So these are the 4 assumptions. My friend, I hope you understood those 4 assumptions of the linear regression. With that being said, I will close this and I'll see you all in the next question.